Welcome to the fourth part of class called Class Based on the Text. So, you wish to learn all about economics? We're going to cover Chapter 5 today, How Technology is Produced. And now that we've covered some ways of measuring the economy, and now we're going to see how science is propagated. Well, first, how science occurs, how breakthroughs happen, and then how to foster those breakthroughs through economic science. So he says he's going to cover two main things. One is the different levels of hypotheses, and this is a funny word because it's used in a very loose way in current culture, as many things that he's referred to so far. Hypothesis, and then how, like I said, to shape society, how to shape your educational system to be able to further hypothesis. So he refers to three different levels of hypotheses. The first one is considered simple hypothesis. And so this is, you run into a situation, you run into either an event, so you've discovered an event occurred, or you're performing an experiment and something happens that's notable. And the first hypothesis you may have, this is the simple hypothesis, is something which fits into the current way you understand things. So basically, you're basing your current hypothesis of what's happening on your existing body of knowledge. Okay? Now, if you want to make the next step, though, you need to make a higher hypothesis, because most likely the thing that you're hypothesizing about, the reason you're hypothesizing about it is because there's something paradoxical about it. There's something that is curious or provoking of thought. So now, for those of you who've worked on Kepler's works, you'll have some sense of it. Even if you've just heard it, worked on some little aspect of it, you'll have some sense of how he dealt with this. Okay, so a higher hypothesis, the way that he defines a higher hypothesis, is something which has to break out of everything that you've previously considered to be the way that you explain everything. So it breaks out of current assumptions. Now, there are several ways you can do this. You've probably heard of, well, there's this. So you can say, okay, this does not, let's do this. It says, okay, in order to do this, in order to make this higher hypothesis, the key is you have to set up an experiment. You have to set up an experimental case, which is such that if your experiment proves true, if you come out with a positive result, it proves the previous body of knowledge completely wrong all the way down. All aspects of the previous body of knowledge have to be proved wrong. And I'll give you a good example. So Kepler took on these different astronomers who had their different theories. And okay, he could have set up his experiment and said, okay, well, your theory is off from observation by so much. Now, maybe that would have pointed out that the other guy's, Ptolemy's or Copernicus's model was wrong, but they could have just modified it a bit to make sure that that particular observation corresponded with their experiment. So in that sense, So now think about this. How do you set up an experiment such that it proves the fundamental basis wrong? And that really gets down to fundamental scientific discovery. When you can get down at what the foundation is and prove that to be wrong. So Kepler set up his vicarious hypothesis and constructed his model such that it took all of the assumptions. It took the basic assumptions of everybody's model and applied that to the extreme. And he with all the rigor beyond anyone else, tried to make this work with observation, and then showed that it failed. And that really was the first step to his discovery. Now, it wasn't the discovery of what it should have been, but it was the first step in this higher hypothesis. It was the first step to say, okay, well, the entire foundation of the previous systems, which were actually all the same, was wrong. Now, I want you to think about this. I want you to think about this in an organizing situation, because this is something you run into every day, right? Something where somebody comes up and you say Ukraine is blowing up, and you know, oh, let me ask you this: what's the response that you get? What are some responses that you get? Initial responses to hearing something like that.
To hearing,
for example, that the U.S. is supporting a Nazi coup in Ukraine.
Yeah, but Putin supporting the Nazis. I mean, that's what we hear in Congress.
Okay, yeah. Okay,
the
so
population's a little bit smarter.
Yes.
Who told you that? Where'd you hear that?
Right.
I get a mixture of both. Either people calling, it's like, well, no, wait, Putin's Hitler, or people saying, oh yeah, I watch RT, I know that we're supporting Nazis, or something, you know, or they're already listening to what's going on.
Okay. Yeah, the first response you get, you can already see the theorem lattice. You immediately see how somebody fits this event that you just told them, something you just told them, into their theorem lattice, and therefore you get a clear, at least some form of, you poked it with a stick, right? You got a sense of what the theorem lattice is. Now, as an organizer, unless somebody's right on right away and is sort of ready to act right away, then you don't need to belabor it. But as an organizer, if somebody has a theorem lattice that is not correspondent with reality, then your goal is to get them to make that higher hypothesis. And so you know that one of the things that doesn't work is to say, oh, no, it's not Putin. Right? Because then that's only disproving some little aspect of their theory. It's sort of, they've got the foundation, they've got all the things built upon the foundation, and you just disprove this part. It's very easy for them to modify that part of it. Well, it's someone else. And so think about that, because I mean, this is what you're doing every day, but Lynn is going to apply this to all of economics. So think about always how to get at to make this experiment, right? To formulate this experiment for people. So now the next step to this hypothesis is to realize that these hypotheses aren't random. So it's not just it's not just making another hypothesis, a different one, because there are infinite many different ones. The question is, how do you make a higher hypothesis? And can that be made? Are we assuming, and he is actually, towards later on, he does say, we've actually already assumed that there are higher hypotheses, that they always go by, it's an ordered set. It's not the case that you just make a hypothesis, say, okay, well, this one was proven wrong, and then you make a different one, and you make a different one, because that would be infinite. And so then he comes down to the third one. So, can you come to know how those higher hypotheses are ordered and willfully work on making those higher hypotheses? And he says you can. Now you're assuming one thing, which is that there is a right, which is that there is something that you are striving toward. And so he's saying, okay, well, this is never going to be perfect. Your hypothesis of how higher hypotheses are made is always a hypothesis. So it's going to continue to be, it will never be perfected, but will become ever increasingly less imperfect. And that's really, that's very important, because it is always something you can continue to work on. But he says, if you don't have this sense of working on this higher hypothesis, this hypothesis of higher hypotheses, then you'll never make a willful fundamental discovery. That people make discoveries all the time. Like I said, this happens on some level all the time. Like making higher hypotheses is just something that human beings do. But to willfully make a fundamental discovery, you have to be working on this this hypothesizing how hypotheses are made, how successive hypotheses are made. And he points specifically at Riemann's habilitation dissertation. Now, he did say Plato works on it, and that is one place to go. But I want to bring some look at a little bit and at Riemann's habilitation dissertation on the hypotheses which lie at the base of geometry. And Jason is going to go through the actual paper, the whole thing, in a week and a half. Probably will take, I think, it will take more than one session, but maybe not. Maybe he will be able to work that. One more thing before I forget. This process of hypothesis is often called the scientific method. Now, the one thing that the scientific method, as far as when I looked on definitions of it, is they do not include this aspect we're talking about right now. So, I'm just going to read, and I should have sent this out, I'm sorry, but I'm just going to read the first section. It's about 2 paragraphs of Riemann's paper, and I won't give away all the juicy parts. Okay, so it is known that geometry assumes, as things given, both the notion of space and the first principles of construction in space. She gives definitions of them which are merely nominal, while the true determinations appear in the form of axioms. The relation of these assumptions remains consequently in darkness. We neither perceive whether and how far their connection is necessary, nor a priori whether it is possible. So often the assumptions that are previously given to how to shape the space in which things are acting are themselves not directly related. and often you can't tell how they are related or if it's possible to relate them. And you'll see this often, as I said, in organizing, where people have assumptions that actually contradict each other. And they don't realize it until you've pointed out that the space that they've formed is contradictory. Okay, so from Euclid to Legendre, to name the most famous of modern reforming geometers, this darkness has cleared up neither by mathematicians nor by such philosophers as concern themselves with it. The reason of this is doubtless that the general notion of multiply extended magnitudes, in which space magnitudes are included, remain entirely unworked. I have in the first place, therefore, set myself the task of constructing the notion of multiply extended magnitude out of general notions of magnitude. It will follow from this that a multiply extended magnitude is capable of different measure relations, and consequently that space is only a particular case of a triply extended magnitude. So he's going to get into he wants to define how spaces are defined, basically. He's going to go into how things are, basically how lattices are created. So not a particular one, or not a particular assumption and their whole formulation, but one, how they're formulated and what they, and show that any particular one, like for example, space, is only one example of it. But hence flows as a necessary consequence that the propositions of geometry cannot be derived from general notions of magnitude, but that the properties which distinguish space from other conceivable triply extended magnitudes are only to be deduced from experience. A little bit down it says, thus arises the problem to discover the simplest matters of fact from which the measure relations of space may be determined. A problem which from the nature of the case is not completely determinate, since there may be several systems of matters of fact which suffice to determine the measure relations of space. The most important system for our present purpose being that which Euclid has laid down. So he's going to take a particular example. These matters of fact are like all matters of fact, not necessary, but of empirical certainty. They are hypotheses. We may therefore investigate their probability, which within the limits of observation is of course very great, and inquire about the justice of their extension beyond the limits of observation on the side both of the infinitely great and the infinitely small. The only other thing I'll point out about this part, and I mean Jason will go through it all that we've discussed, but the only point I want to point out is that this idea that these so-called matters of fact are hypotheses. Right? They're not factual, but they're hypotheses. And that he points out that, you know, like what Kepler dealt with, which was all these different models, the only way that you, well, not even the different models, but the different systems, whether it's the one that Kepler is continually formulating within his new astronomy, or the one that the other three astronomers that he was contemporary with were working with, those have to be determined by experiment, basically. So, let's see, what do we do? Okay, good. Okay, so the next section that Lynn goes through is really getting at this question of the theorem lattice, which we discussed just now. But he's really getting at something. He says this is related to the subject that we just discussed on hypothesis. And getting at this question of cause. How do you communicate cause? And he uses this example of a cork. So he says the cork is this funny thing because you introduced it as it was derived mathematically. And so therefore you can't disprove that it exists, because you're ordered to use the mathematics that derived the cork to prove that it doesn't exist. Does that not make sense? So if you were to say, okay, well, this cork doesn't exist, then somebody will say, well, prove that it doesn't exist. You go to the blackboard and you're using the mathematics to prove that it doesn't exist. But the mathematics were the ones that derived the cork in the first place.
Right.
And so therefore you can't disprove it.
Right.
Now that's actually a very funny case, but he makes this point, he brings in the cork because it and several other subatomic particles are sort of being used to build up the universe from the small. Which means that cause, in this case, in the universe, is a conglomeration of these little point things that exist on their own. Their own existence they have a self-existence. And then everything else, which means that everything else is dependent on the existence of this thing. He says, if you believe in this addition version of space or of anything, then even if you're not an astronomer, you still believe in the quark. Right? Even if you don't know about it, and you don't even know what it is, and you've never dealt with, you're not a physicist, and so on, you still believe in it. And so then the question is, well, how do you get out of that? And that's really, for the next 2 chapters at least, that's really what he's trying to get at, is how do you communicate something not as a point that existed outside of anything that had an instantaneous existence, but how do you get at transformation? And some of you guys know, for those of you who did your homework, how this works. He says if you look at the difference between using transitive verbs versus nominalism, you already get a sense of this difference between what he's pointing out, the difference between points and what he calls singularities. And so I'll give you an example. The British Empire is in the tradition of Zeus. Okay? Versus the British Empire serves Zeus. Is that saying the same thing? Or, this is another one. We are very tired today. Or, versus, work tired me today. Now those are that's sort of a sentence form of what he's trying to get at. Does that make sense? Does that difference make sense?
Say it again.
Okay, so the first one was, we are tired. And the second one was, work tired me. Hard work tired me.
The difference is...
Yeah, what's that?
I was just saying the difference I was thinking about is just one is acting on... Something is acting on something else, and the other one is just kind of a statement about what you're feeling or something.
Yeah, right. The other one actually is it's sort of a statement of existence. And you probably notice that a lot of the to be verb doesn't really have another. A lot of the other verbs had transitive forms. As long as you use them right. If you use them like rain, that was a funny one, right? You could use it rained or it rained cats and dogs. And so a lot of these verbs were able to be one or the other. Some of them couldn't be. Some of them continually transitive verbs. To be was continually an intransitive verb. Now he brings all this up really to get at this idea that of transformation. That you always, when you're looking at events or you're looking at a scientific discovery, it is false and untrue to be able to, if you state the existence of something that is instantaneous. And we'll come back to, well, he says from this that therefore in order to study, to make policy, basically study science, you have to study the history of science. You have to be able to understand a transformation, a flow of how discoveries occurred and how society was actually created. There's several points in here where he explicitly says this should be part of curriculum. And if I were you, I would note those points. Not all parts of those things that he's pointed out have we actually worked on. One example is in the footnote, in the second footnote, he says every secondary school student should read through this book on Da Vinci. I think it's called Leonardo da Vinci. That's the title of it. So, how many secondary school students? How many people in this movement have read that book?
Mm-hmm.
But anyway, the other thing, many other things which he points out have been working on, but you get a sense of how he's developing those as a necessity. One more thing I want to point out about his this discussion of cause. He says we've already assumed that there is some form of universal, right? To say that there are higher hypotheses, they're ordered, and that there are higher versions of hypotheses of higher hypotheses means that there's something universal you're striving toward, and that something universal must be not only transitive, but because there's nothing beyond it. It also has to be self-reflexive. That was just an interesting conclusion to come upon. Okay, so the end of this chapter is then society and economics. So then the question is, knowing this, knowing how breakthroughs are made, and that economics is based on breakthroughs, how do you foster this? How do you make it a science? How do you use, how do you integrate this, what he's just discussed, into economic science? And there's a couple of things that he points out which are really interesting. So first of all, he says, okay, we've discussed negentropy. We've discussed that it occurred that the fact that human society exists proves that one, these steps of higher hypotheses are true, work, or orderable, and that two, that human society uses them. The fact of existence of human society proves that this works. Says, okay, you see this negentropy in economic science, you see it in life, and the next step would be to uncover it in astronomy, in the large. As universal as possible, he says, as far as the very, very large, I think this is Riemann. It's very difficult as a scientific question. So it's sort of a trivial. It's not trivial, but it's a question that's hard to make an experiment for. And so, but you can uncover as large as possible nega-entropy in astronomy, and it'd be very important. And so then he poses a problem to the labs. And he says, what you want to be, what you want to foster in the labs are these lines of inquiry that get at some aspect, get at some part of this nega-entropic process in the large or in the small, but where you can demonstrate that the universe is as you see in economic science and in life, overall, everywhere. And he has this funny statement that you should cultivate a wildly omnivorous appetite for startling discoveries. I just thought it was funny. So, and then he has a short but dense discussion on how to foster this creativity. And one of the things he says is, okay, well, one, concentration is very important. And for scientific discovery. And often concentration gets broken for emotional reasons. Well, how do you deal with that? And actually, I'd like to ask this maybe risque question. How do you get yourself back on track when you lose your concentration?
Well, Lynn said at one point that when he gets frustrated himself, that he picks a fight. Meaning that because when you're being potent, you're doing something political, and it gets you reorganized.
Mm-hmm. Anyone else? I'm sure everybody loses their concentration. Probably losing it right now.
A short spell of listening to violin quartets can sometimes help you resume concentrated effort.
Okay.
Yeah, I was going to say music.
Music, yeah. Okay. Anything else?
Pavel, were you going to say something?
I've just been reading things about psychotherapy recently, where a lot of it has, it has to do with trying to find ways to address the subconscious, and because I think in some of it is. Sometimes people have a reaction to having an emotional crisis, which is just trying to suppress the emotional response rather than addressing the cause of it, which can seem to work in the short term, but usually creates bigger and bigger problems later on. Sometimes to a point where people can't deal with it at a certain point, and they have to get treatment, which is oftentimes too late.
Right.
But that's what a lot of people talk.
Can people hear the responses from over here?
Yeah, I can.
Yeah?
Mm-hmm.
And that one makes it ironic because picking a fight is somewhat of an example, but most of if you try to discover most of the causes of emotional problems people have, if you're a Freudian and you look at your childhood and maybe your parents and things like that, but it's mostly an effect of different historical phenomena.
Yeah. Actually, so I guess it makes sense that Lynn's response is most close to Lynn's own response. So the way that Lynn discusses it in the book is that he attributes the emotional response which causes you to lose your concentration or to regain it is largely as a product of personal identity, which makes sense that you would sort of pick a fight because then you refresh your personal identity of what you're actually doing. So it comes down to a sense of personal identity, and I'll just read really quick how he discusses it. He says, so you have that a human being, an individual, has to be able to foster a sense of himself, a sort of a self-importance, I guess. And that's not to say that you want the person to be able to be concentrating on getting others to feel that he's important. That's not what you want. Instead, the objective is you must foster an inner directed sense that the individual who contributes to society in this way is an important as well as useful individual because of not only his creative powers, but his commitment to further development and beneficial use of those powers. He must have an inner moral sense of identity. And he contrasts this, so this is sort of a negative proof. He says, actually what's happened over the past, since the 50s even, is the opposite, where we have a society which disapproves of long concentration spans, or of having a real mission that extends beyond your life, such that you're disregarding things that seem to be very important, like success and making money and your family and so on. Things that, you probably heard from your family. But he goes through this lobby, and most of us have now discussed it a couple times, but the white collar strata came in. He said, it's actually very indicative in this statement. I'm a vice president for my company, and my plumber earns a higher hourly wage than I do. This is upcoming of the white collar strata, and this accompanying philosophy that the secret to getting ahead in life is cheating. And I think he's got it right on. So it is a societal aspect as well. Yes, there is. There's a couple of things you can do, but overall, even those things are tapping into something that's broader. He's saying it is this certain sense of identity that you end up trying to recall while trying to get back your concentration. Or it's that you've lost the sense of identity that makes you lose a sense of a longer train of concentration.
There's a story about MacArthur. Mm-hmm. He was, I don't know any of the specifics, but he was at a certain point dazed by the challenges before him, and just sort of lost briefly, and then he pulled out his pipe and he smoked his pipe, and then he remembered who he was. And that's also kind of the same kind of experience that everyone has, where you kind of somehow you bring yourself back to who you really are, despite the noise around you.
Right. Yeah, it doesn't just work to say, okay, concentrate. You end up just staring at the same thing. Focus, yeah. That doesn't work. Right, like you said. Anyway, so that's part of the society's role in economics, in fostering this capability we just discussed of making higher hypotheses, making real scientific discoveries, and upshifting these values that we posed earlier of real production. So now, before he brings up an educational plan, there's one more thing that I want to point out, which is he goes through the labor force. And for some of you who did your homework, you might find this funny, or you might want to puke. I'm not sure which one. So number one, he says, so here's you have to have an emphasis in employment patterns that must be on 3 crucial points. One, I'm reading off page 107 for those who are following. 1, raising the percentile of employed operatives within the total raising the percentile of employed operatives within the total labor force to about 50% of the labor force. Number 2, concentrating the increase in expansion of the capital goods producing sector of industrial production. But before I go to the last one, what was the actual operatives, the employed operatives in the non-service sector in our economy? People find that? You remember?
It's 12%. See, that's what you were asking?
Yeah.
Yeah. The percentage of people. Actually, wait. Hold on a second. That's the percentage of people of the total work eligible labor force. So otherwise, it's something like 20% of all the people who are actually working. It's something like 20%.
Yeah. Yeah. I think for almost everybody that it's about, like you said, it's about 12 to 20%. So 20% of the labor force is doing something useful, basically. Is not in one is not service. Let's see. Yeah, one is not service and 2 is not waste. So he says we have to raise that to 50% of the labor force, and to weigh it heavily on people producing capital goods. Okay, so number 3 is to increase the employment in research and development to 5% of the labor force. Now, I did not look this up. I thought about giving it as a homework question, but I thought it might be mean. Well, how about this? Can people throw out some hypotheses of how you would look for what percentage of the labor force is research and development? Probably didn't find it in the labor statistics.
That's your like very, very skilled people.
Yeah, well, people who are not in the direct, may not be in direct production, but they're doing research.
Okay. Grants and universities.
Grants and universities, yeah.
I don't know if that give you a number of people, but it could give you some sense of, yeah, what.
Well, he says this is labor force. Yeah, he's looking at.
Well, the problem I'm thinking about right now that would come up would be what's actually considered as scientific research.
Right. That's true, yeah. And one thing I'm thinking is, if I were to try to do this, I think I would probably call into a company like Northrop Grumman or, a pretty large company and ask them how much of your labor force is in research and development, because they would know.
Sometimes they publish statistics.
What's that?
Sometimes companies publish statistics on these things.
Yeah, or sometimes I think it's easier to call, but yes, you're right. They probably do publish it somewhere. I'd probably call and ask them where they publish it. This is faster to talk to people. Anyway, so he says to raise it to 5%. I don't know what it is now. I do actually doubt that it is anywhere near 5%. Okay, so the last thing in this chapter, we're sort of running out of time. is his discussion of the educational system. He says there's, you know, he actually proposes that we have training centers. He calls them seed crystal laboratories or training centers. The training centers should be focused on mathematical physics from the standpoint of synthetic geometry, the history of science from the standpoint of primary sources, and those should be, and a sense of where the new frontier should be. All that from the standpoint of where the frontiers of fundamental breakthrough should be. And just read this last paragraph. Added to this curriculum he just laid out, the proliferation of knowledge and use of a form of economic science, which links directly the production of economic value and fundamental issues of scientific research, will provide the basis for coherence between economic management and research, which a science driver national policy implies. So this, being able to order the cohesion, being able to provide some kind of cohesion of economy and research, is implied in this idea of a science driver. Okay, let me see. Do we have time? No, let's leave that. Okay. All right, let's have some discussion. I'm just trying to figure out if we should go into chapter 6 or not. Should we go for an hour?
Do we go for long? Do we go for an hour and a half?
Let's do it. Let's go into chapter 6 because chapter 7 chapter 6 goes pretty well with chapter 5. So it's pretty short. So chapter 6 is on work and energy, and it's a similar case. You're talking about technological progress and how to measure it. And you saw work before. Actually, you saw both. You've seen work and energy. Work was very interesting. He said work was related to a measure of negentropy. Right, he said your economy of labor, your economic value is based on the amount of negentropy it can create. And that creation of negentropy is what he defined as work. He says, okay, there's two things that increase the energy content of your system. And one is the increase in potential relative population density, which is closely related to your increase in energy flux density. And the second one is to increase your energy per capita. So that one's easier, right? One's you're increasing your capital input, your capital goods, your both for the household and for in total, right? You're increasing your production. You're increasing your capital intensity. In that sense, you're just increasing in overall the energy per capita. But that the way that you define, so now has anybody here taken like physics besides you, Paul? And run into these words, work and energy? Anybody in the audience there? Usually the word work and energy, they're defined as a number. So there's some number that you get that's considered work, and some number that you get that's considered energy. You do an equation, you put it down, and it equals a number. And you may already see that trying to measure the energy of the system is already posing a lot of difficulties as far as posing like a unified number to energy. or to work. Like how do you measure the neg entropy of a system? He said actually what you're gonna two things. One, his hypothesis, his proposal is you have to take this as a hydrothermodynamic function. And we could probably get into that in discussion if we want, but that if you take the work of Riemann, which you guys will go through in a week and a half, the work of Kusa, this arc from Kusa to Riemann, then you'll have the foundation to be able to sort of to be able to create a function for the measuring of work and energy. And okay, and then he says, okay, in order to get science, current science, to be able to assimilate this, to be able to take on what he's just now defined as work and energy, two things have to be addressed. Actually, one thing has to be addressed, and it actually is what we just discussed, which is the subject of elementary particles versus singularities. Because chemistry, which is the way that they discuss work and energy are determined, chemical action right now is based on elementary particles. And if you were to reform that, you'd have to be able to take on chemistry as in the form of what we discussed earlier, which is that everything is a singularity in a he calls it a hydroelectrodynamical process. Largely because the elementary particles don't take into account really basic things like life, and definitely don't take into account economics, human economics. So I'm going to stop there in chapter 6, and maybe Jason will go through a little bit more or decide to elaborate on it. There will be a homework problem on it, and open it up for discussion.
Is it hydroelectrical dynamic process?
Yeah, what do they call it? There's several concatenations here. Hydroelectrodynamical process. This gets into some of Moon's work and so on, which is very cool. Would be. I don't know if you guys want to discuss it, we can.
Well, without having, I don't know if you can answer this without having gone through the whole chapter, but why does he call it work versus energy?
Why does he call the chapter work versus energy? You know, I had a very different idea going into it, and then when I read it, it seemed like, I mean, it seemed to me like the difference between energy flux density and capital intensity.
Oh, really?
Yeah.
But I'm not really sure if that's true. Yeah.
You're saying where work would be capital intensity?
Work would be energy flux density.
Oh, okay.
And energy would be capital intensity.
Okay.
But he's using it. He uses energy as well as using capital intensity. So they're not equal. He says they're related. What was I going to ask?
Some of that in why it's the whole distinction that he has between dead and living force. Similar. Because energy is a potential, but what that potential is going to produce is not defined by the potential. Because the work is the thing that actually produces something from the potential that exists. And in that process of producing something, it's like some of what you were bringing earlier. It's not just equivalent to expending the energy. Especially if you're trying to produce a state of society that's more productive than before. It's almost like having more energy in a certain sense, at least accessible to society than before. So that how you use the potential is not the same as just the potential itself. But yeah, it involves a lot more the human ability.
So for plants, the sunlight's the energy, and the soils, the raw materials, the plant's the capital that does the work. Make your food. So it's the process, is the conversion of energy, which actualizes the work. Not its existence as a potential or as.
Yeah, that could be a good example because, you know, it's we've given some of those examples, like the difference between just having a solar panel or having, you know, plant life. Because if you take, you know, it's the same energy, but or fracking versus producing food, right? You can have the energy, but you're going to starve your population. It's not. If you just took the electrical energy from a solar panel or the energy from fracking, it doesn't mean you're going to survive as a society just because you have that energy.
It doesn't have the same value.
Right. Right. It's not, in some sense, it's not capable of doing the same work as, you know, having the plants. That,
Very real sense. The reality is you don't eat.
Yeah. I want people. Are people thinking about teaching this course? I'd start thinking about that now. So we're about halfway through the book. I'd start thinking about the material in the book from the standpoint of teaching it. And what I used to do, with my contacts is, you know, you call them every week. You may just give them a briefing or whatever. But I'd take a chapter out of this and tell them, I'm going to teach you economics, and then go through one chapter a week. And it won't be the whole chapter like we just went through today, but just some aspect of it, some idea, maybe the distilled idea, and try to work them through it. But start to think about examples and work with examples for your contacts, and maybe for homework you could write down some responses you get. And also, well, anyway, were there any questions from the homework? There were some very good, fun responses. I think Jason might go through it.
Is there a homework for next week that's been prepared?
Yeah.
Can we go over that?
You want to go over what the questions are? Sure. So these are tentative. I think I'll add some. Or I'll add some and take away some. chapter 5. Do you want me to read them? Is that what you want to ask?
Yeah.
Okay.
Yeah, it'd be good for everyone to hear what it is.
Okay. So here's the homework. It's not that long. So chapter 5, Lynn writes about the Actually, you know what? Can someone else read this?
I can read it. Okay, let's start from there.
Yeah.
Okay, homework. Personal identity / socializing discovery. In chapter 5, Lynn writes about the transformation of identity from what people produce to what they consume, and the rise of the quote-unquote playboy identity. Question 1. Find a couple of advertisements from the 1930s and compare them to modern ads. Who do the advertisers think they're talking to? Who are they trying to sell their products to? About halfway through chapter 5, Lynn knows your attention span is flagging and talks about attention spans, relating the ability to maintain concentration with personal identity and mission. Question 2. When you lose your concentration span, how do you get it back? In this chapter, Lynn has some very clear directives for education, including in footnote 2, where he says, quote, in a well-ordered educational program, every pupil would have worked through the scope of this book, Leonardo da Vinci, New York, 1938, before graduating from secondary school. He has since said that about Kepler's 2 main textbooks. He has a strong focus on synthetic geometry and working through original works of Cusa, Riemann, and others, so that individuals have a sense of creative identity and can see themselves in a process of ongoing history. Finally, he proposes quote-unquote educational brigades, which turn out brigades.
Question right there.
Okay. Question 3. Do your contacts depend on you for education? Do they organize others? Levels of hypotheses. Question 4. Define and give an example of a single hypothesis, a simple hypothesis, and a related higher hypothesis. Lynn writes that Riemann's habilitation dissertation is a hypothesis of the higher hypothesis. It is sometimes said that everyone is a philosopher, even if they don't realize the philosophy they're acting on. Even if you don't think that you have a
hypothesis of a higher hypothesis.
Okay.
That's what the H's stand for, by the way.
Okay. You actually do have a hypothesis of the higher hypothesis. What is your idea of a hypothesis of the higher hypothesis? Events and singularities. When Lynn discusses the idea of a theorem lattice, which builds everything up from a self-evident assumption, he uses the example of an assumed quark, which is used as a building block for all atoms and therefore the whole universe. He contrasts this idea to the objects or events being created as singularities generated by a process of transformation. Question 5. Write out 2 short briefings someone might give. One that treats the ongoings in Ukraine as a point, and one that treats it as a singularity. Question 6. Cut out or find 2 circles, and by folding, create a line and a point. Also, cut out and fold or construct with pencil, compass, and straight edge an equilateral triangle inscribed in a circle. Science and economics. Throughout the book, and again explicitly at the end of chapter 5, Lynn relates economic value with fundamental issues of scientific research. He says that a science driver provides a basis for coherence between economic management and research. Question 7. What is your current idea of what a science driver is?
I haven't written this one yet.
Okay.
So I'll have to add one for chapter 6. Or more.
Those sound fun.
Okay, good. Maybe more people will do them. You can still do them, even if you haven't done the others.
Could we email them to some of the staffers?
We'll work on that.
We're working on building the audience from the staffers in Congress. They need to learn about economics, even if they don't wish to learn about economics. Okay, any more from you guys?
See, the book for them would be called "You So Wish to Read It."
All right, let's end it there. Great. We'll see you next week.